Hey there, everyone. I hope you weren't waiting for Amy because today you are with Miss Pryia. Today is Math Wednesday with the Learning Liaison. We are here for you and your math needs. As always, you know what I like. I like math, so let's go ahead and just get started. Question number 1 is brought to you by geometry. It is a middle school, high school type of problem. It's definitely something that scares a lot of people. A lot of you out there see a shape. Shapes bother you, pictures bother you, words bother you. You think that math should only be about numbers, but math is so much more than numbers. Math is about critical thinking. So let's go ahead and work our way through this problem based on what we know. So the problem does tell us that if the measure of angle P is 123 degrees, we're using a lot of words, less symbols. So let's go ahead and put what we know down. We know that this guy over here, which is the angle, is 123 degrees. Then they're asking us our question, and our question says, then what is the measure of angle Q? Angle Q is over here. So we go back to what we know and we go, okay, what am I supposed to do? I have 123 degrees, I have Q, I have P, I have 15. Let's go ahead and make that 15 a little bit more distinct and let you know that that is degrees. And that's pretty much it. We just have this thing on top of a line, and that thing is called a triangle. What do we know about triangles? This is where you start critical thinking and you just go, okay, what do I know? This is your brain dump. We know that triangles, all of the angles, add to be what? 180 degrees. Okay, is there anything else that we could think about for triangles? They have angles, they have sides. Sides are called legs. I don't really know anything else about triangles other than that quick little bit of information. I know that there are tons of names for triangles because there are different types of triangles, but we don't have any of those cases here. We have this triangle on a line. Does anybody know anything about triangles, angles, and outside angles and all that good stuff? Can anybody help me out? What am I looking for? I'm looking for a theorem. And just because I said theorem doesn't mean it's scary. It just means you got to dig a little deeper for some meaning to this one. So there is a theorem, and the theorem that we are actually going to use to help us here is called the exterior angle theorem. Let's talk about that really quick. What does the exterior angle theorem mean? That cool little alligator with a half moon, that is my angle symbol. So we have the exterior angle theorem. So if I just drew a triangle, I'll draw another triangle. This is what we're going to use. If I drew a triangle and I labeled my angles, I'll number it 1, 2, 3, and I'll name that outside angle, angle 4. The exterior angle theorem tells us that the sum of angle 1 and 2 will add to equal angle what? So the sum of angle 1 and angle 2 will add to equal what? They will add to equal angle 4. So that really helps because what do we have right now? If we renumber our angles based on what we just used, this would be 1, 2, 3, and 4. Let me use a different color so we don't get that mixed up with what I have already. Red's a good color. 1, 2, 3, and 4. So if we relabel our angles and we use the exterior angle theorem, what are we looking at here? We are looking at angle 1, which is 15. So we will have, based on the exterior angle theorem, 15 degrees plus I don't know how many degrees is equal to 123 degrees. That makes it really easy for us because I can just go ahead and solve for my x and figure out what that angle 2 is that we labeled just now. So I'm going to go ahead and use regular algebra. I'm going to subtract 15 degrees on both sides. And when I subtract 15 on both sides, my x is equal to what? 108 degrees. Okay, great. Now that I have x, is x the angle that we're looking for? Is X the angle that we're looking for? Can I go ahead and say that 108 is my answer? Wham, bam, thank you, ma'am. Move forward, and we are done. No, wrong answer. That is not the answer that we are looking for. That is a great angle that we needed, and we used it, but it's not the answer. So let's go ahead and plug in our information based on what we now know. 108 degrees goes there. Okay, what are we looking for? We're looking for Q. Q is this lovely highlighted green over here. Q is on the outside of the triangle. So how do I figure out Q? I can look at this and tell you a property that I know based on just looking at it. And it might make more sense if I kind of do something like that. Hopefully some gears have been turning. You have an idea of what I'm looking for. I'm looking for somebody to tell me that that is a straight angle. Straight angles have how many degrees? Straight angles are how many degrees? They are 180 degrees. They never change. They are a straight line. They're 180 degrees. So if we know that a straight line makes 180 degrees, then if we redrew that Q and 108, just to make it a little bit more clear, this is what it would look like. 108 goes over here, and I don't know now, goes over there. Let's relabel it as the actual letter that we were given, Q. Okay, so I have 108 in Q. If two angles for a straight line will add to be 180 degrees, how do I figure out what Q is? I'm going to add Q plus 108 to equal what I said it will, 180 degrees. Now, how do you solve regular algebra? Go ahead and subtract 108 on both sides. I apologize. And Q is equal to what? It's definitely not 108. Can't be 138. What are we left with? What is Q equal to? Hopefully my math serves me right, and our answer is 172 degrees. I apologize. Winner, winner, chicken dinner. Okay, so no, you didn't have to go with the straight angle route in order to solve the problem. There is another approach. You could have solved using some other type of math. There's lots of different ways to solve a simple problem. As you all know, that's what math is about, right? This is the approach that we took. So does anyone have a question based on what we did? Maybe you did something differently and got the same answer, and you just want to know to make sure that you did it correctly. That's what we're here for. Okay, if you have any questions, I'm going to go on to number 2. And if it comes up in the chat, because I'm watching it, I will go back. Okay, number 2 is brought to you by the lovely algebra. Yes, I know. I love it. It's one of my favorites. It's a middle school, high school type of problem for algebra. So when we see problems like this, we don't have just a plain Jane, select one and move forward. We have a select all that apply. These problems are a little bit more tricky because now you have to make sure that you're paying attention. And if you're not paying attention, you might miss something. So when you answer these questions, it's always best, especially to get this stuff off of your computer screen, right? We're all taking time tests here. That's the purpose of all of this. We're all going to be certified and we're taking a time test. In order to get through that time test, get things out of your brain and get them on that little laminated sheet, what they provide to you. So I would write A, B, C, and D on my little laminated sheet or whatever you have. So let's say that this is the sheet of paper that they gave me. I would do this. And when I do that, the purpose is to get out of my head what I like and what I don't like. So as we're answering this, I'm going to kind of show you off to the side what it would look like if I was taking the test, and then it would be how I would actually answer the question without having my iPad, right? Because I know a lot of you are like, hey, that's unfair. You've got an iPad. We don't have an iPad. We've got to take the stuff off the screen, so we're a little bit behind. But this is how I would do it if I was on a time test. I would write A, B, C, and D down. And this would be my little paper. Obviously, I wouldn't write it this large, but it would be on my paper, and this is what I would do. I would go ahead and read the question. It says, which of the following represents a function? So first things first, I know that I'm looking for what? I'm looking for a function. And before I even start answering the question, I ask myself, what does it mean to be a function? Well, I know that there are lots of definitions to function. So instead of just trying to write all of the definitions down, I'm going to go ahead and look at my answer choices. And my answer choices are giving us what? These answer choices are giving us tables, or giving us charts, right? So I'm going to base my definition of function on what I know about tables and charts to help us. So here with my two tables, I know that for a function, we need what? It says for every x, there is one y value. One y value. What does that mean? It means, in other words, that x's cannot repeat. It means that you cannot have two x's or one x that maps to two numbers in the y side. So when we're looking at these tables, it is a given, known, without having to state, knowledge that the left-hand side, yes, it's the left-hand side, the left-hand side is the x and the right-hand side are your y's. It is also known without having to state it that the left-hand side is your input, which means that your right-hand side would be your what? Output. These are more helpful to understand what's going on, right? So if we had an actual linear function or an equation that we would plug these values in, I would, based on C, I would plug in 1 to my equation. I'd plug in 1 to my equation, and my answer would be 3. Okay, that is what you would do. In this case, we don't have a function to actually plug these values into, so we need to know the definition that we wrote earlier. For every x, there is one y value. So 1x to a y, not 1x to 2 y's. That makes sense, right? So let's start with A. A says 3 goes to 2, 5 goes to 0, 7 goes to 11. I did not repeat any of my x's, so right now I'm going with A as an answer choice. And I would do a little check mark or circle it because I like it on my little paper, right? So then I'm getting this information out of my head. Then for B, it says the input and the output. So 3 to 7, 9 to 30, 11 to 14. So far, so good. That is still a good answer. Now, if I was doing work, I would do work next to my A, B, C, and D so I wouldn't get them confused and mixed up with. So then when I get those answers, it would be easier to answer the question. For C, C tells us 1 to 3, 9 to 3, and 8 to 6. So a lot of you may have questions here. And the question is this a function or is this not a function? That's the question that we're asking ourselves right now. Is it or is it not? Shall it or shall it not be a function? Remember, we said that an x has to be mapped to one y. You cannot have one x to the same x to two y's. So the same value cannot be repeated to a y. In this case, we have every individual x, so every x that is on its own, does not map to no one number in the x value maps to two numbers in the y value. So C is a good representation of what's going on. I forgot that we had an E, so I'm just going to add that to the bottom. Now, what I was just talking about was over here, if you look down at D, 1 goes to 2, 3 goes to 2, that's fine. But now the problem that we have is 8 goes to 0 and to 11. That right there is our problem. Our x now maps to two y's. Two y's is a no-go. So then E is also a no-go because 7 maps to 1 and to 5, and that is an issue. So our answers here, because we have more than one answer, is A, B, and C to define a function based on the inputs, outputs, or the tables, or the charts, however you like to call these diagrams, what they're represented with. Questions? Okay, I'm going to keep going forward, and you're going to be here. So if you have any questions, we can always come back to them. Number 3, probability and statistics. I love this stuff, but it also makes my head crazy. So our question isn't too bad. It's a middle school, high school problem, and it reads, the average of 5 numbers is 20, and the average of the first 4 numbers is 12. What is the 5th number? So right now your head's probably spinning. So let's take what we have and let's put it down on those little papers that we're talking about, right? So right now, what do I know? I know that the average of 5 numbers is, remember, is represents equal, 20. And the first 4 numbers is 12. What does anybody know about average? What does anybody know about average? Let's take average and turn it into words. Don't tell me how to solve it. Tell me what you do. Like, what is average? Average is what? Average is equal to what? Average is also the mean. I'm probably spelling all these words wrong because I'm talking and spelling all at the same time. So let's try that again. Average. Okay, here we go. Average is also known as mean, right? Mean, average. When you're solving for the mean or you're taking the average of something, you need the sum of all of your data. So you'll need the sum of the data. And you do what with that data? That sum, you then take it and divide it by the amount of numbers you have. So we need the sum and we need the amount of numbers to get the average. Well, based on the first line, average of 5 numbers is 20, that kind of gives us some different type of information that we're used to. We know the average because they said the average is 20. So we actually have 20. 20 is average. So we're going to plug that in a little differently this time. So for the first set of information, we're actually going to say that 20 is equal to what? Do we know the sum of the data that we've been provided with? I don't know it. Do you know it? If you know it, you got more information than I have. Right now, based on what we have, I don't know the sum. So I'm going to label the sum as X. But I do know how many numbers I have. And based on the first sentence, I know that the average of 5 numbers, which means that I have 5 pieces of data in total, and 5 is my denominator. Okay, a lot of you hate fractions. Fractions didn't do anything to you, right? We don't discriminate. So we look at the problem and we go, well, how can I solve for X? And the only thing that should be coming to mind is, I got to get rid of that 5. That 5 just makes this so ugly. The 5 and the X are connected through what operation? The 5 and the X are connected through division. And the opposite of division is what? The opposite of division is multiplication, which means we are going to multiply both sides by 5. Those 2 5s go away. I missed it. Those 2 5s go away, and we have 5 times 20. 5 times 2 is 10. Add the 0 from the 20 is equal to X. What does 100 represent? 100 represents what? 100 represents the sum of the 5 numbers, not our answer. They gave us some more information that we're actually going to use. So in the second piece of information that they gave us, they said the first 4 numbers, so out of the 5 numbers that we have, the first 4 of them, 1, 2, 3, 4, the average is 12. We're going to do what we have again, but this time we're going to do things a little differently. So let's keep going. I didn't mean differently yet. We're not doing things differently. We're just still using the information that we have. So based on the number 4, the first 4 numbers, the average is 12, and we know that the average is equal to the sum of all that information divided by how many numbers you have. In order to solve for x, you have to do what? Multiply both sides by 4. Go ahead and do the same math. Say goodbye. 4 on the other side. 4 times 12 is what? 48 is equal to x. What does that represent? You should be screaming, and I should hear you all the way in New York saying, the sum of the first 4 numbers. I heard you, I heard you. It's the sum of the first 4 numbers. This is important. Why is it important to know that that is the sum of the first 4 numbers? Let's read our question again and ask ourselves what we're solving for. What is the 5th number? How are you going to find the 5th number? Come on, how are you going to find the 5th number? If you have the sum of all 5 numbers and then you have the sum of the first 4 numbers, how are you going to find the value and how much the 5th number is? This is where it gets fun. You're going to use the sum of the sum of 5 numbers, subtract the sum of the first numbers. Why does this work? I'll show you really quick. So if I had A, B, C, D, and E, those are 5. If all of these add to equal 100, but these are 48, how do you find that guy? That's what we're doing. Okay, ready? Here we go. Almost there. Okay, so we now have the sum of the 5 numbers, which is 100. And let's do this a little differently. Let's do this more of how I just wrote it out. So if we had 5 numbers, A plus B plus C plus D plus E, all 5 of those numbers would be equal to 100. The first 4 of them is equal to what? 48. So we have 48 plus E. We're going to call E the 5th number. 5th number is equal to 100. So let's go ahead and solve for E. I think this makes it a little bit easier for you instead of me just wording it out to you. So we need to subtract 48 on both sides because we need E all by itself. And E is equal to what? 52. So our answer here is 52. So I only used A, B, C, D, and E, just to be clear. I only used those to give you a representation of what's going on, to give you a visual representation of 5 numbers. So these are just made up numbers. These are made up numbers. Just to represent the 5 numbers that we have in total, and then the 4 numbers that make 48, to represent the 5th number that we don't know, to represent the total that we know, which is 100, and to help us solve for the number that we needed, which is now 52, and we are done. Winner, winner, chicken dinner. Okay, they're not so bad once you start getting into them, right? But it's all about dissecting the pieces of information that you were given and seeing how you can use that to move forward. I know a lot of you end up tripping up on this because sometimes you're like, ooh, this is a tricky question. Yes, it's a tricky question, but it's not that tricky. It's still kind of straightforward. So when you're answering questions, don't try making them more complicated than they normally are. Don't worry, I'm still really good at that, so you are not the only one doing that in your life. It happens to the best of us. Okay, here's another probability and statistics question, because I just said I really like them today. So for this probability and statistics problem, we have a high school / middle school type of problem. And it's not too complicated, but it's about knowing the information that you need and knowing how to get through it. So question 4 says, there are 8 pencils and only 1 is green. Okay. I don't know what we're doing with that yet, but no problem. Let's keep moving. Then we have 5 notebooks, and one of those is purple. Okay, let's keep going. Then they ask us a question. What is the probability of randomly selecting one green pencil and one purple notebook? Does anybody have a clue of what's going on? We have a pencil and we have a notebook, and remember, only one of those pencils are green and only one of those notebooks are purple. So would it just be like 2 out of 13? Because I would just add the 8 and the 5, get 13, have 2 of those things being selected. Wham, bam, thank you, ma'am. Moving on with my life. No, not at all, because if it was that simple, I wouldn't be here trying to help you find it. So what do we need to do? We need to understand what is going on. First things first, we read the question again and ask ourselves, what are we doing? We are randomly selecting one green pencil and one purple notebook. How many items are we selecting? We are selecting 2 items. We are selecting a green pencil and a purple notebook. So with 2 items being selected, I will have 2 fractions that are being multiplied to each other. So fraction 1 multiplied by fraction 2. Okay, the first fraction represents our what? The first fraction is representing our green pencil. 1 green pencil. And remember, the bottom is always the total. So how many pencils do I currently have? I currently have 8 pencils in total. Out of the 8 pencils, how many green pencils do I have? I only have 1, so 1 goes in the numerator. Now we go to, I could have done this the other way, but it's going to end up being flipped colors. I apologize. Now we go to the notebooks. We're selecting 1 purple notebook. How many notebooks do we have in total? We have 5 of them. And how many purple notebooks do we have? We have only 1 purple notebook. Can you tell me how to solve 2 fractions that are being multiplied? How am I multiplying? Am I multiplying 1 times 1 or 1 times 5? 1 times 1 or 1 times 5? I should hear you, and you should be yelling, I'm going to multiply straight. You are multiplying straight, which means 1 times 1 is 1, and 8 times 5 is 40. So the probability of selecting 1 green pencil and 1 purple notebook is 1 out of 40. Wham, bam, thank you, ma'am. So these, like I said, they're not that bad. You just have to know what they're asking you. As you know, if you have any questions, you know what to do. Let me know. So this was one of those special requests. It's probabilities of, this is not really probability and statistics. It's a trig problem. I'm sorry, I don't know why that didn't change over. So this is more of a trig problem. The trig problem is that we have to figure out what's going on with the period of this function. But if you don't know what's going on with the function in a whole, then you don't really know what's going on. So there is a form that this is currently written in, and it is the regular vertex form of this problem. So let's go ahead and kind of like identify what we should know in this equation. So we will have the standard form, which looks a little like this. Bx minus c and plus a d. A is my what? A is my amplitude. Amplitude is how high from the middle of the sine function it goes up and down. Then my b is my period. Period is solved by saying 2 pi over the capital B, which is B there, the value. C is my what? C is my phase shift. This is how far horizontally the graph has moved. And then D is my vertical shift. And vertical, like vertical lines go up and down, so how far up or down the original function moved from, what a regular sine function would look like. So we're starting to add all these components to move the function within a whole, right? So when we're moving our function, it's doing all these things, and then we're adding all these numbers, and that is how people know what we did to it. So when we look at this, let's identify our amplitude. Our amplitude right now is -2. Our period is not that, but we have to solve for it. We're going to use that number in front of the x to help us solve. Our phase shift is going to be C, and D is our vertical shift, and we actually don't have one in this case. So it did not go up or down. And when I say up or down, I didn't mean by a stretch. Stretching and shrinking, like compressing, that's our amplitude. How far up, how long it's stretching, and how small it's being compressed. That's our A, that's our amplitude. When I say vertical shift, I mean if I started here with my pencil, if I started here, I physically moved from here and I now start here. So I went up, or I could have gone down. That is what I mean by vertical shift. So we now go back to the problem, and it's asking us for the period of the function. So in order to solve for the period, we know that we need to do what? We need to have 2 pi over b, and let's plug in what we know. Well, I know that 2 pi stays 2 pi, and the number in front of my x right now is a coefficient of what? It is a coefficient of 1. You can't see it, it's there, you just don't remember it's there. Because if I said I have 1 pencil, it's the same as saying pencil. It's still 1 pencil. I didn't say pencils, so I don't have to have more than 1 of them, I only have 1 of them. So we have x, which means that we have exactly 1 x. I did not say 2 x's. So we only have 1 of them, and we put the 1 under the 2 pi, and our period here is going to be 2 pi. These aren't too bad, like I said. Once you understand what you're supposed to know, it does make it 10 times easier, I promise. Here's another trigonometry problem brought to you by high school and college level math. So our trig problem here is a word problem. So the problem before, let's look back at that. The problem before was just simply a function problem. They just gave us the function and they just pretty much said, okay, well, based on what you know, can you go ahead and find the period and just kind of give us an answer and move on from there? Well, this problem now that we have is no longer here is the function for what I'm giving you. I'm now asking you to determine the function. So we actually have to use information and be accurate with the information that we're given in order to solve the problem. We can't just say, okay, well, this can easily be solved because the equation is there and I can kind of like pick through it. You need to have more than basic knowledge on this one. So you actually need to be able to use the formula that we just wrote down. So our y is equal to a sine or cosine, doesn't really matter. We don't always have sine and cosine in this case. We will have x bx minus c plus d. In this case, because we don't have sine and cosine, we will have a squared function because generally when you have no sine and cosine function, that is the formula that we have. So this is kind of like one of those things. Somebody else came up with the formula. They did all the math for us. Let's not make it more complicated and more harder on ourselves. Just remember what you're given. Just know the formula, use it and abuse it, move on from it. We don't have to figure out all the y's and the little itsy bitsy pieces in the middle. But because we know the formula, we can use what we have in this lovely question in order to plug our information in and move forward. So let's go ahead and read it. It says a toy rocket was launched from its base from the height of 2 meters and reached a maximum height of 50 meters with a horizontal distance of 20 meters. Determine the equation to model the path of the rocket. Wow, okay. Let's start again. A toy rocket was launched from its base from the height of 2 meters, which tells us that the rocket was not sitting on the floor, which means that we have to account for that. So if we had to draw this, there would definitely be some artistic skills required in this case. So let's go ahead and draw what we know. Off to the side over here, I'm going to draw. And we are starting at 2 meters. It is important to remember that it says that it is launched from the base from the height of 2 meters. So it's on its base, and from the base, it is 2 meters off of the ground. That rocket, let's see if I can draw a little rocket ship. A top, a bottom, and 2 little sides, and there's a fire. Okay, there's our rocket ship. Our rocket ship is now launched, and it reaches a maximum height of 50 meters. So I'm just off to the side over here going to say 50 meters. It doesn't have to be perfect. I'm going to draw a little dashed line. So now my rocket is going to hit the 50 meters. Remember, the shape that we're drawing here is not a straight line. We are not going to launch the rocket off into space and it just go out there and never come back. We have to draw a line that is a curve, and the name of that curve is it's a parabola. So here we go. We are going to now draw the path of our lovely toy rocket. So here it starts, goes up to 50, doesn't pass 50, and then comes back down. And remember, it doesn't have to be perfect, it just has to show what we are trying to tell it. Well, aside from that 50, they told us it reached a distance of 20 meters. Is that the entire distance when it hit the ground again? So like, should I put 20 meters over here? No, 20 meters does not go there. 20 meters goes right where the rocket was at its highest point. So I'm going to read it again, and then we're going to determine that it is the highest point. So a toy rocket was launched from its base from the height of 2 meters and reached the maximum height of 50 meters with a horizontal distance of 20 meters. So what they are telling you is when the rocket was at its highest point, all the way up there at its highest point vertically, horizontally, it was at 20 meters. And that is what we represented there. When we are looking at this, a lot of you may go, okay, but that A, B, C, D stuff doesn't help us. It's because there are multiple ways of writing equations. So if I change the equation form and I wrote it in a different way, hopefully that kind of helps you out a little bit. So what if I said y is equal to a times x minus h, all of that squared, plus k. Hopefully your spidey senses are going off and you're like, ooh, I know how to do that. I know how to do that. The reason I said that is because we're kind of missing some information here, right? I can't just take 50 and 20, plug it into 2, and then I know exactly what I need to do. I need to start plugging in the information based on what I know from the problem and the diagram that we drew. So from the diagram that we drew, you should be telling me that the vertex, that's the maximum point right in the middle of your lovely parabola that you would have drawn, your vertex is what? Your vertex is 20, because that is your x value, and 50, because that is your y value. And it's a point. That's your point. Your vertex is 20, 50. Based on that, you should know that your vertex is represented as h, k. Yes, you should, and if you don't, tisk, that is something you need to know. I will rewrite that because I realize how bad that looks. H, k. H, k. Okay, now that we have our h and our k, let's go ahead and plug it into the formula that we have. So now we have y is equal to a times x minus 20 squared plus 50. Is that an answer choice? No, it is not, which means that we have to solve for a. That guy right there. How do you solve for something that you don't know what you're supposed to do? There's another point here, and you're supposed to know that. So based on some background knowledge and other information that I have found from the interwebs, I know that I will also need to use this value right there. And that lovely value point is the point that I need in order to help me solve and finish being solved with this problem. That point is labeled what? I have 0x, but 2y. So that point is 0, 2. Why is this important? I now have an x value and a y value. And if I plug an x value and a y value into the equation that I have, then I can solve for a. Because right now what I have is 3 letters that are unaccounted for, a y, an a, and an x. And those 3 letters are not going to go anywhere unless I change it or do something with it. So I'm going to plug my 0 and my 2 in. So I have 2 is equal to a times my x is 0 minus 20 squared plus 50. So now I'm going to solve. 2 is equal to a, and 0 minus 20 is minus 20 squared plus 50. I'm going to subtract my 50 on both sides, and then I'm going to square. You know what? Let's just follow PEMDAS. Let's not make it worse. So PEMDAS says that I'm going to square my negative 20. So negative 20 times negative 20, a negative times a negative is a positive. So I'll have positive 400. And now I'm going to subtract my 50 on both sides. Minus 50 minus 50. I'll have negative 48 is equal to a times 400, which is the same as 400a. It's however you want to write it. To solve for a by itself, go ahead, divide both sides by 400, but you're left with this really ugly number. Okay, so we have options here. We can figure out what's going on. All we have to do is figure out what we were given. You may have a calculator. If you have a calculator, this is going to be easy. You can go ahead and reduce your negative 48 over 400 fraction and get a reduced fraction form of that. Once you do that, you'll be able to plug it back into the original equation that we came up with, that we solved with for a, and then you'll be able to get your answer. And if you don't have a calculator, and if you didn't want to use your calculator, there's kind of an easy thing here that we should be looking at. We are still going to solve the problem, but before we do, let's just look at what we have. I have a negative value there, which tells me that a is going to be a negative value. I cannot reduce my fraction and get rid of that negative, which means that a is a negative number. Well, D does not tell me that A is a negative number, but B does tell me that A is a negative number. So my answer, without having to use my calculator and do all that hard work, is to say that my answer is B. Sometimes you don't have to do all the work, you just have to realize what they're trying to tell you. If both of these numbers were negative, you would have to figure out something else, because then we would just have 2 answers that are correct, which means that we did something tremendously wrong, because it does not say all that apply. You can only select one answer here. So let's finish doing the problem. We already know what the answer is, but let's go ahead and see how we get 3 over 25. I know that 4 goes into 48 and 4 goes into 400. So I'm not going to make this difficult on myself. I'm not going to try extremely large numbers and make this hard. If you have a calculator, go for it, but don't waste time. Right? And if you don't have a calculator, go with the easy numbers. Don't make it harder on yourself. I know that negative 48 and 400, both numbers, are divisible by 4. So I'm going to reduce them, and I'm going to get negative 12 over 100. That's way easier to work with. I know that 12 and 100 are both divisible by 4 again. How do I know that 100 is divisible by 4? Because I know that I can get $1 with 4 quarters. I can break it up into 4 pieces. So I will now have negative 3 over 25. You can try, but 3 and 25 do not have anything in common to make them more reduced. So this is as reduced as we are going to get. And since a is negative 3 over 25, it is the same as saying all is negative 3 over 25. Remember, we just don't like fractions that have denominators that are negative, but we can take out the negative in the numerator or the denominator and make the entire fraction negative instead. So there are options here. It's just understanding the problem and trying to figure out what you were given. Vertex, yes, is an XY point. However, vertex is represented by H and K, and H and K is what's going to help you plug those numbers back in to get the value of the A that you need in order to move forward on this. And you know what to do. If you have questions, you go ahead and throw them in the chat and I will answer you. Okay, number 7. Number 7 is about algebra. We all know how much I love algebra. So our algebra problem here is to simply simplify what we were given. It can't be that bad if it's just a simplify situation. So what are we going to do? We're going to simplify, but we need to know our rules in order to be able to simplify. So before we get started on the problem, let's just talk about some other types of math. Let's do some examples. So if someone gave you the problem 2 squared, let's make that 12 squared. What would you do? You would tell me that the answer is 144. How did you get there? You would have done 12 times 12 to get 144. So we know that 12 squared is 144. Okay. Now, what if I told you 4 squared, that being squared? So let's not make this complicated. Let's just do the math together. So right now, we're going to do what's inside the parentheses first. And inside the parentheses is 4 squared. Let's change the outside number to a 3. So the inside number is 4 squared. So 4 squared is what? It is 4 times 4. And 4 times 4 is 16. I'm going to grab my calculator because my brain is about to do some funky math. Now we keep the outsides, and the outsides tell us what? The outside tells us that whatever that number is, we are now going to cube it. Take it to the 3rd power. So now we have 16 cubed. So that tells us 16 times 16 times 16. I apologize, I did not mean to write X's for my multiplication. Keep them as the dots. So 16 times 16 times 16 is 4,096. Okay. If I wanted to manipulate the original problem, how could I rewrite that with one exponent? Would this now be, so let's go off to the side. We have 4 squared, and that's being cubed. Now we have 2 options here. Is 4 squared to the 3rd power going to be 4 to the 5th power because I did 2 plus 3 to get 5, or is it going to be 2 times 3 to get 6, and I would have 4 to the 6th power? That's the question here. Which one of those is correct? Well, the only way to do it is to physically put it in and figure out what we get. So I'm now going to do 4 times 4 times 4 times 4 times 4. And when I do that, I get 4 times 4 times 4 times 4 times 4. That lovely guy is equal to 1,024. That's not the number we're looking for. But if I do 4 to the 6th power, 1, 2, 3, 4, 5, 6. That's the number I'm looking for at 4,096. So what do we have here? We have a rule, and our rule is called the power of power rule. Go figure, because the power, the exponent has a power. So our power of power rule, let's write that in here, power of power rule. The power of power rule tells us if we have a letter that has an exponent and that exponent has an exponent, that we are simply to multiply our exponents to get the new value. So we are multiplying those numbers. So 2 times 3 is 6, and we get 4 to the 6th power. Now that we know that, we can now do this problem. And remember, we're not taking the exponent and giving it. We're not giving it. We're not giving it into whatever we have. It is not a distributive property. To do a distributive property, we would have had to have a number on the front outside, not an exponent. Now, the 12 could have been distributed. The thing about the 12 is the a cubed b squared is only one term. So I would have had to write something in the middle to indicate that they were separate. Now you can give them to both. Now you can give the 12 to both. But if it's all one term, it all goes together. So if you're taking one bag with all your pieces of clothes, it's still one bag, right? That's what's going here. So this is our bag, and these are the pieces of clothes that we have if we did not have the addition sign. So it doesn't matter if you have one bag or all the pieces of clothes, it goes all together. Okay, so now we are just going to do what it tells us to do, and it tells us to just simplify. So right now, if I had to go ahead and expand that, we'd write it out, all the letters. A times B, and it says it's being squared. What does that mean? We can write this two ways. We can say A cubed B squared, which says A cubed B squared times A cubed B squared. Or we can just use the property that we just learned, and we're going to do it both ways. Of course, we're going to do it both ways. This, based on the power of power rule, tells us that we're going to take the exponent and multiply it to the other exponent. So a to the 3 times 2 and b to the 2 times 2, which gives us a to the 6th and b to the 4th, and that is going to be our answer, which happens to be a. But if you want to do it a different way, that's okay. Remember, the squared on the outside says whatever you have on the inside, multiply it by itself. So let's go ahead and multiply it by itself. When we multiply it to itself, we get the same term, same thing twice, right? Now we're using a different rule. Now we are multiplying bases that are the same. So now what are we doing with our exponent? When we are multiplying bases that are the same, so let's say multiplying same bases, what are we doing with our exponent? We are adding exponents. Remember, this is two different ways to solve the same problem. So what am I doing? I'm looking at my a cubed and my a cubed, and I will write a cubed times a cubed, which tells me I have a to the 3 plus 3, which means I have a to the 6th. So far, so good. Now I'm looking at my b squared and b squared, which tells me I have b squared times b squared, which tells me I have b to the 2 plus 2, which is b to the 4th. And remember, they're being multiplied, so we're not changing our operation here. We're keeping the operation the same. And we're going to have the exact same answer by solving it a different way. And remember, I talked about that earlier. We can do math in multiple ways to get to the same answer. The question is, are you doing math right? Well, that's all I have for you guys today. So if anybody has any questions, please, please, please feel free. Oh, I still have one more problem, but we don't have enough time to do this problem, but I can write out what we can do. I forgot about this one. Sorry, guys. This is a matrix. It is a linear algebra problem. We go from left to right on the first matrix, and we go from up to down on the second matrix. And what we are doing here is we are multiplying our matrix. The matrices are going to be multiplied, which means that you have to be able to write out the steps or solve, and this is best done on paper, not in your head. We should have time to do this. These aren't difficult problems. So if I'm going from left to right, I'm going there, and then I'm doing this. And that is helpful to know because that is how we place our numbers. Okay, when I'm placing my numbers here, it's all based on everything that you see. So let's go ahead and multiply our two matrices. So a matrix turns into a matrix when you have more than one. And we are multiplying a 2 by 2. That is what the first matrix is called. And we're multiplying it by a 2 by 2. So we have 2 rows, 2 columns, 2 rows, 2 columns. So they're both a 2 by 2. So we have a 2 by 2 and a 2 by 2. The numbers on the inside match up to tell us that we are able to solve this, and it actually tells us that we will end with a 2 by 2. And if you end up with something else, you have done something wrong, unfortunately. So now we're going to do exactly what it says. We are going to multiply and multiply. So I'm going to multiply my 1 by 5. And let me draw a blank. Multiply my 1 by my 5, and I'm going to add my 2 times 7. 1 by 5 and 2 by 7. And then I'm going to do my 1 by 6 and add my 2 times 8. And then at the bottom here, I'm going to have the other one. I'm going to do my 3 by 5 plus 4 times 7, and then 3 by 6 plus 4 times 8. Hopefully I did my math and we have an answer choice that actually works out here. Sometimes my math comes out a little wonky. So what will we have? 5 times 1 is 5 plus 14 gives us 19. Sometimes it's good to just kind of keep them in order as you're going through them. Then I have 5 times 3 is 15, plus 4 times 7 is 28, and that will give me 43 or 50. 43. My brain's trying to do everything at the same time. 1 times 6 is 6, plus 8 times 2 is 16, and 6 and 16 will give me 22. And the last guy at the bottom down there, 6 times 3 is going to be 18, 18 here, and 18 plus 4 times 8 is 32 to give us 50. And our answer is right here. Wham bam. Okay, so they're not that bad. You just have to make sure you're bookkeeping on these. And I almost ran out of time, but we did it just in the nick of time. So, as always, what am I going to say to you? A big fat thank you. Thank you for being here today, and thank you for showing up. We like doing math for you, and if you like us doing math for you, then we also have online tutoring. We have a one-to-one session, and we have our boot camp. There are lots of things there. We're always looking out for you, so come by and see us. We'll see you soon. Bye-bye.